Now we are. Thanks. Welcome to CS210. What you missed was me talking about the 6 days. That's all. All right, so this is our first conditional statement. We are, for those of you who just joined on the video, we're basically picking up where we left off in the previous lecture. Right? That's true, that's false, end of story. Let's look at another one. We're down here. We can chain them together. Oh, I don't need that. I have them over here probably. Sweet. Here's chaining them together. If I've got several conditions that I need to test. So for here, for example, I want to know, is food greater than 42? Is it less than 42? Is it actually equal to 42? So this will let me do that. And I can just use this else if statement to chain these if clauses together. So if it's this, do that. Else, if it's this, do that. Else, if it's that, else just do that. There's no condition there. So this actually acts as a kind of a default for us. It'll do the conditional tests. If everything's false and I get down to here, then I'll execute that print statement, but only if I've got foo greater or less than 42 already. So this whole thing is the if statement in that case. Let's run that one. What's that one? 3C, test 3. So enter an integer, and we're using scanf to do it, just like we did on Tuesday. I'm going to input that into foo, and let's do 5. So 5 is less than 42, right? So it should print too low and then get out, too low. Let's do it again, and we'll do the big one, 45. That was too high. See how this works? And now let's do 42 exactly. So in that case, neither of these initial conditions, or none of these guys are true because it's exactly equal to 42. And so it should print just right. And does it? It does. Any surprises there? Shouldn't have any questions on that, right? Nice save. All right, cool. We'll see yellow if I put 42.0. So my answer to questions like that is almost always, I don't know, let's try it and see. Because, like, just try it, right? 42.0, just right. But it's just right because 42.0 is a float, right? Yeah, and here I'm comparing it to an integer. It didn't do what you expected. Oh, actually, maybe it did. Maybe it did do what we expected. Hang on. Let's try it again and do like 30.0 or 5 or something. So that should print too low. Actually, it did print too low. Why did that work? To be honest, I don't know. We'd have to let's do it. Let's just, I'm going to put a breakpoint in. Let's do a quick little debug session here. So let's hit, there's the scanf. So I'm going to put a breakpoint right here. Jonas, if you enter a character, characters are just numbers. We'll look at that in a sec. So it would treat it as an integer, actually. Let's put a breakpoint here. So this is debugging in this Visual Studio environment. Basically what I'm doing is I'm telling the runtime, I want to run the program and then stop on this particular line. And I get the line by just, see over here on the left, I've got these red dots. Just clicking in that margin will set a breakpoint for you. And you can see all your breakpoints down here. So if I put one there, for example, you'll see down here on the lower left, I've got a breakpoint list. Let me just get rid of that one. So I've just got one, test3.c, line 6. Now I'm going to go here, this build and debug task, and I got there by hitting this debug sort of run sort of thing, this thing. That gives me access to that. It's also up here on the menu, start debugging. We'll just do it here. So it's going to, it actually does several things. We'll talk about debugging in nauseating depth at some point. It's essentially building symbol tables for us so that we can relate the variables and where they're defined back to the line number. There's a lot of stuff, extra stuff going on here to allow us to run this program and then stop it at some point. So you can see it's now compiled with symbols, and I'm going to enter an integer. Let's just try a normal one first. Let's give 44. There's our breakpoint. And you can see over here, locals, that's my local variable. So foo has the value 44. You can actually change it if you want, by the way. You can make that 6 or something. These little controls up at the top of the screen, these allow you to either single step through the program. So this is your single step button right here. Do one line and then stop again. This will run to the continue button, runs to the next breakpoint. And then these guys step into and step out of. We'll talk about functions next week. If you have a function and you want to step into the function and debug inside the function, you can, or you can step over it and just execute that single line and then go to the next line in your code that called the function. And that restarts it for you. So here we are. So that looked fine. Let me keep going. Cool. And let's run it again. We'll put a, take a sec, it's going to build all the symbol tables and such. Blip, 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 blip. Enter an integer, and let's do like 42.123. Oh, interesting. That's what happened. That's what's happening. Now, my question is, and I actually don't know the answer to this. I'll have to think about it and put it up on Piazza for you. Like, is scanf actually doing conversion there? It sure looks like it, doesn't it? Looks like it's converting that based on the, maybe that's why they call it a conversion specifier. We didn't really notice it on printf because we already had a variable and we were just outputting it in a certain format, but it didn't change the variable itself, didn't change that value. It just sort of converted it on the fly when it printed it. But here I'm actually reading it in and telling it, hey, I want to convert this to an integer, I believe is what's happening. And it did it for us. That's interesting. That's a little scary. Like, I mean, I understand why it's doing it, but logically, like if I expected an integer there and I typed in a float, it's going to have to do something to convert that. Like if I type, let's actually keep going. Let's try one more. So that was 42.123. Let's type like 42.9 or something. See if it's rounding or truncating. 42.999. And what we get is 42. So it's just truncating it. That could be an issue. Yeah, that could be an issue. I guess it just really depends on what your program is intended to do. Just keep that in mind, that scanf conversion operator is actually doing a conversion for us, it looks like. And we could be certain if we might do this when we get further in the course, we'll be doing like serious, like memory level debugging. We'll have to stop a program like this and inspect memory at that point and see how that variable is laid out in memory. Did it really lay it out like an integer, or did it lay it out like a truncated float? Is it better to scan with the %f? But if you're using ints, like if your program's using an integer, I don't know. I guess it just depends. Yaro. All right, off we go. Sweet. If you've got a bunch, it's a conditional statement. If you've got a bunch of these, so if you've just got if this, else 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 if this, you probably are writing an AI program, but there's a cleaner way to do that. It's a joke. It's a joke. You know, that means AI is just a bunch of if statements really fast. If you're writing a bunch of if statements, there's a much better way to do it. And frankly, if I'm looking at code and I see just if this, if this, if this, if this, if this, that tells me that this is a programmer who doesn't know what they're doing. they just know a little bit about the language. It's, like a high school or junior high school student would write code like that because they just don't know any better. More mature programmers would use a switch statement here instead. Switches look like this. And I've got it over here somewhere, switch. This is what a switch statement looks like. And we were playing with this. Get rid of that. Cool. Who was it that asked about ASCII? Oh, it's Jonas. Yeah, Jonas. Characters, like a single character. In fact, if I just do this, like char letter, chars are 1 byte values. That's the only thing that you're guaranteed a certain size of in C on any platform. Characters are always guaranteed to be 1 byte. Ints are guaranteed to be larger than a character, and so on. But that's kind of the foundation. Chars are 1 byte. It's just a number. So, for example, a space character is really the number 20 in hex. An A, like a capital A, is the value 65. A lowercase a is 32 plus that, so 89. They're just numbers. They're stored as numbers. They're treated as numbers in your program. The only time it's actually a character that we can read is when we read it. Like, it's just for us, really, so that we can read stuff. But they're stored as characters. You can see them over here. Do I have an ASCII chart? Bicycle to ASCII chart.
I have a question.
Yeah, sure.
Oh, I'm loud. If you would enter, like, if you scan for an integer, what would happen if you enter then a string? Would then only be the first character would be taken, or would it like cause an error, or what would happen then?
Let's try it. I know. So the question was, what if we had entered a string? I don't know what it's going to do. Sorry, I'm looking up. It's a synagogue. I'm looking up, right? There's no Baruch for C. I don't know. A string is stored in memory as a series of characters. The variable that holds the string really is just the address of that string in memory. And then the string itself is terminated. We know it's the end of the string because there's a \0. There's a kind of a null character at the end of that string. I don't know how it's going to treat it. But in fact, let's put a breakpoint in. Let's go back here. Was this our code? Yeah, I do have breakpoints. Wait. Let's see what it looks like. Well, if I just type a string on the terminal, it's only going to look at the first character of that string, I think, and probably convert that to an ASCII value. So it's going to look like an int at the end of the day. Let's do one we know. So what's the capital A, 65? A time for all things. And we got foo there. Why is that? Oh, it's a 0. So now the question is, like, where did that 0 come from? Let's try a different string. Too low. Oh, I've got to do it from over here, don't I? You guys missed the rant on that I did in A1 about Visual Studio Code. Another 0. So it looks like it doesn't appear to be, I mean, it's not a runtime error, but it's certainly an unexpected value. We'd have to do something a lot different if we actually wanted to capture a string here on the terminal. We haven't talked about strings yet, but as I said, strings are really just a character array is what a string is, with a terminating null at the end of it. So the variable that we stuffed this into would have to be a char pointer, or a character array at least. Can you print foo? Well, it gets printed down here. Let's just kind of print a 0. Well, we can. Let's print it right here. With like this conversion, right? Let's, Jesus. Can I tell it it's a string? Try it. Let's see what that does. Yeah, for strings, we're going to use scanline or getline. And we just keep going. We get, oh, we get a null. You know, it almost feels like it's reading the character string from the console, and the last thing it sees is that terminating null, and it's setting it to 0 or null. I don't know that for a fact. Different function input strings, yeah. It's a, yes. And in fact, we'll use different functions to do that. Even scanf has some awkward stuff in it. We're going to end up using things like getLine instead, which is cleaner. Interesting. Switch. We're going to switches. All right, here's our switch. It's essentially an if statement. So here's the switch itself. Same thing. I'm going to enter some value and stick it into foo, an integer. But based on what I enter, if I enter a 3, this case gets executed. If I enter a 2, it does this one. If I enter a 1, it does this one, and so on. So it's just going to match what I typed in and then do the right thing for me. Let's just run this one. What's this one called? Switch? Do we change that? Oh, no, it doesn't. Sweet. Yes, I can tell you that too. Oh, so let's type 3. 3 is my lucky number. Sweet. Let's run it again. 2. It's going to run the case 2. Do 1. That's interesting. Why do you think it did that? So it did 1 is the loneliest number, which I kind of expected, but then it also printed out not graded directions. Like, why did it do that? Doesn't it? Yeah, yeah, no break. Forgot the break statement, right? So in switches, that break statement, see them all up here? That break statement gets you out of the switch. So the switch itself is everything from there to there. That entire set is the switch. Anytime you hit a break statement, it gets you out of the switch. And we down on line 25 at that point. So I just need to put a break statement in. That'll get me out. Why does it go in backwards order? I just happen to write it that way. It's not necessarily in that order. It's doing a match. It's a pattern match. If I wanted to use chars here, I could use characters. In fact, I've got this character variable letter up here. So I could do it this way. So instead of at foo, I'd put it in that letter. Like that. Let's see if this works. And that's going to be a character instead of, actually, it doesn't matter. Character is an integer, so I can just leave that alone. But now I can do things like this. A, B, C, that. It'll work exactly the same way. And, you know, frankly, behind the scenes, what's going on is, like I said before, that ABC is just for us. Really, when I type the A, that lowercase a, the number's a 97. That's what's being stored, what's being read, a 97. But C allows us the convenience of not having to memorize the ASCII table. So let's run this one. GCC-O switch. C. Enter 1, 2, or 3. Let's enter a B. So it should go to takes 2 to tango. Yeah, and it didn't. Ah, screw you. Why? Why not? Why not? Oh, I didn't. Did I save it? I thought I saved it. Why? Which statement? Oh, the switch. Oh, thank you. we do pair programming, right? Thanks God you spoke up, because I was about to make something up. Oh, here's why that works that way. All right, B. We got good directions. Should have been takes 2 to tango. Why is that? So sweet. Now I got to freaking thinking about this. Let's see what happens if we do a C here instead. Oh, interesting. So that is not what I expected. So the way I fixed this was I just changed that scanf specifier to a C for a character. My assumption was because these are really integers being stored that I would, oh yeah, that's why. Anyone know why? It just hit me. Yeah, but what's the difference between an int and a char? How are they stored in memory? What are the sizes of the two? Yeah, somebody had it over here. A char is 1 byte, and int is 4 bytes on this machine. And so that char was being stored, because I said the scanf, remember we realized that it's actually doing a conversion for us. When I said convert this to an integer, I said, oh, it's a 45. It was probably stored in memory as 0, 0, 0, 0, 0, 0, 0, 0, 0, 0, and then the 45, the binary for it. So it's 4 bytes instead of 1. That's fine. And then we were actually switching on a character type. And so it's just looking for 1 byte. Stick or saw. Yeah, you got it. See all the cool stuff you learn when you take C? Like you'd never think about that in Java, would you? Or any other language. You have to keep this in your mind all the time. Like what's happening really in the computer. That's why this is computer fundamentals. Like this is how it works. That's cool. Oh, and this uninitialized line here. Let me just put a back end in there so we can see it better. Save it. So this right here where it says foo has an uninitialized value of 0. That's just luck. That is just luck that that's a 0. Here, when I defined foo, I declared it rather, I did not define it. Declaration just says what's the type. Defining it gives it a value. There's no value here. I just said it's a type, right? And so now when I go to use it, if I'm using foo somewhere, like it just, what's the value in there? It's just whatever happened to be in memory at that spot while we ran this program. So you're not guaranteed of a value at all. It looks to me like, because I've run this a couple of times now and gotten zeros, it looks like when this container fires up, or when the program is fired up at least, the memory that's associated with the program is all initialized to zeros, is my guess. So that when I just reach out for a variable that I've never put a value into, it still has storage associated with it. It's just going to read whatever happens to be there. It happens to be zeros because that's what the runtime did for us. It initialized all that to 0 for us. That is not ever guaranteed. For example, no one asked about this. Oops, that dead beef thing on Solaris machines, and I think a couple of others, maybe the Next Cubes, a couple of other boxes, they initialized memory to DEAD BEEF, the hex value, because a really common way to debug, and we're gonna do, you guys are gonna do it too. I'm not gonna do it because it's a pain in the ass. I'm gonna ask you to do, well, I've got to show you though. We're gonna debug memory. You basically just do a dump of memory and then read it and see what's in memory. Oh yeah, that's over here. Oh, no, that's not good. And so it's easy to see uninitialized or initialized memory that hasn't been used if it has some cool pattern. Like dead beef is just really easy to find when you're reading something. I got a great story about that, but it's really long, so I don't think I can tell you. Then debugging is easy. Don't make any errors, yeah. Oh, that's not good. It's like the lock-picking lawyer, right? Oh, this isn't good. There are 3 pins here. All right, so that's a switch. Anything else cool in there? No, I don't think so. So switches. Here's the third way of doing it. And you may never have used this in Java, but this is a feature of Java. Of course it is, because Java is written in C or C++. It's, I just have it over here, it's easier to see. It's this operator. So it's this question mark colon thing. Question mark colon. And so what I'm doing here is I'm going to input a value, foo, and then I'm going to do this foo percent too. Percent is just the modulus operator. And what that means is that I'm going to divide foo by 2 in this case. And then the modulo is the remainder, the leftover. So if I have, say, the number 6, 6 divided by 2 is 3. Is there a remainder? No. So that's going to return a 0. Is 5, like 5 divided by 2 is 2 with a remainder of 1, right? So that this value is going to be a 1. It's just a cheesy way to see if something is even or odd, because I can do that. That's going to return always 0, 1, 0, 1, 0, 1, 0, 1, depending on whether it's even or odd. And then I'll just use that as my conditional. That's my true false, basically, and then print out those values. So if this returns a 1, I'm going to do this one. If it returns a 0, I'm going to do that one. Oops, this one. That one, even. Let's run this one. By the way, that was just a control C to get out of the program. This one's called cond. Enter an integer. We'll do it as 6. We just mentioned 6. 6 is even. Let's do an odd one. 7. 7 is odd. You only have 2 choices here, the true and the false. You also, by the way, could, I've done this in the past, I probably shouldn't have. You can use that conditional operator to set the value of a variable depending on either of the 2 conditions. So a equals, for example, foo equal 2, yes. In one case, it'll be like this. You could say like int a, int some long var name, because I don't like a and b, equals, and then do something like this, foo %2, question mark. I wonder why that's not giving me that. Oh, thank you, it was just slow. And then do this, like divided by 2. So we can say, like, you know, I don't know, doesn't matter. So if foo modulo 2 returns a 1, then a gets the value 30. If it returns a 0, a gets the value 20. So you can set the value variables that way. It's a nice shortcut. I actually use that operator quite a bit because it just saves, you know, 2 or 3 lines of code. And it's because it's in every language, like we all kind of know what it means. So it's not some unusual thing to use. It's like, no, it's, everyone knows what that is. No reason not to do that. Yeah, 0 is false, 1 is true. And when somebody's going to ask me that in any moment now, why are we returning false? I don't know. We just do. That 0, by the way, so that return statement, that is not parsed. Come on. That's not parsed by C. That's parsed by the operating system. So the operating system runs a program. It then examines the return value from that program to determine what to do next. So it's really that piece. It's the OS saying, hey, if it's successful, I want to see a 0. If it's not successful, I want to see an error code. And error codes are non-zero, typically, just sort of by convention. So I can return an error code here, in which case any error code means there's something that's gone wrong, or I can return a 0, which means that all is well. Any questions about that conditional statement? That's an easy one, right? Sweet. You guys seem to be smarter than A1. Don't tell them. All right, what's next? Oh, let's loops. Let's talk about loops. So that's conditional statements. Let's talk about 3 different ways to do a loop, because who doesn't want to talk about that on a Thursday afternoon? 3 different ways. 2 of them are related. So the question we're asking really is, do I know ahead of time how many times I'm going to do the loop? And doing a loop just means I'm going to execute some block of code more than once, or I have the potential to execute it more than once, over and over and over. Do I know how many times I'm going to do it, or do I not? If I know how many times I'm going to use it to run the loop, I'm going to use a for loop for that. So this is a for loop, which I've got over here. It's a little easier to read. This is handy. We save a lot of time in here because I'm not copying stuff over and typing. It's great. All right, so here is the for loop. So I've got this counter. I'm starting it at 0. And the way loops work is, so I'm initializing some counter. That happens once. Then I'm going to do a test. Here's the test. Is the counter less than 3? The first time through this, counter is 0 to start. So 0 is less than 3 for sure. If that's true, if that statement is true, I'm going to run the body of the loop. The body of the loop is everything between the curly braces. So that's the body. So in this case, counter is 0. It's going to run the loop. When it gets out of the loop, executes that last line in the loop, it then does this, counter plus plus. Counter plus plus just means I'm going to add 1 to the counter variable. That's why like C++ is 1 better than C. That's exactly what it was. You guys know what language came before C? What was C based on? B. Yeah, it was based on B. Yeah. I know. It's like computer scientists have like really limited humor. Like that, it's basically that sort of joke. It's like, oh, but it's true, right? It's like it's funny because it's true. Oh yeah, it was B before, and then when we worked on it, made it C. There is, in fact, a language called D. I don't know if there's an E or not. Might be like a D++ or something. Why not A? Why not both? Haha. No, Andrew, D, there is a D. C minus minus. C minus minus is when you run it on Windows. Microsoft gives us a lot of money. I've been told not to disparage them. But you all know how I feel, right? All right, cool. So that is our for loop, right? Let's run this. Let's compile it first. GCC dash O for .c. Now what happened? GCC dash O for .c. 4. All right, so in this case, it's going to run it 3 times, right? If you start the loop from 0, like they should be, then that test value tells you how many times the loop is going to run. If you start it at 1, like beginner students do, then it's going to go counter less than 4, but it's going to run 3 times. Like that's pretty silly, right? So we start at 0, and it just tells us, oh, it's going to run 3 times. End of story. Enter an integer. 5 is odd, 4 is even, 3 is odd, and we're all done. It ran 3 times. Is counter plus plus the same as plus plus counter? Let's try it and see. Actually, let me write a new file for that. And let's call it plus.c. I think I've got time to do this. Include standard IO, because we're going to use that one. Int main void. Oops, I didn't mean to type that one. Yep, like that. What was the question? Oh, plus plus and plus. Hang on. So let's do this. Int bar equals 6. Printf and we want to see bar. It's going to be dot like that. space, bip, like that, asterisk, comma, semicolon. What did I miss? None of this. Meanwhile, you know, everyone on the chat is like answering the question. And it's like, oh, and I'm like, oh, let's just try it. And I'm, all right, we're gonna try it. There we go. Now what did I screw up? Oh, it's not that, it's bar. Perfect. So that's bar, right? Now let's do this. Oh, I'm gonna do it even better. Let's do copy that, copy, and we'll paste it a couple times. Like that, and we're gonna do this. Because we wanna watch bar. I guess I didn't have to print them, did I? I could have just done it with the breakpoints. Let's go build it, run it. I didn't return anything, and that's okay. Let's stick it in for me. All right, so here's bar. So I got bar 6, right? Now we're going to just execute this line of code. So it's just going to print it. So it prints it. Now bar is still 6. Now it's going to execute this line of code and do bar plus plus. So now bar is 7. What do you think is going to get printed next? Yeah. It goes to 8. Why isn't it printing anything over here? Keep going. Nice. Let's just run it. Why isn't it printing anything? Bar 6. Oh, because I didn't give it a specifier. Jeez, I paid. Back to JavaScript. That's fine. So it prints 6688. 6688 is what got printed. There's no 7s. Where'd 7 go? So that's a postfix versus an infix operator. If it's on the left, it does plus plus first, and then I got the value bar. If it's on the right, it does the value bar and then increments it by 1. So depending on left or right, it actually does the plus plus in any case, and just depending on whether it's left or right, it does it first or last. So keep in mind that also, we're used to just writing blah plus plus, right? Sometimes you need plus plus bar or plus plus blah. Like there could be situations where you need that. So they're different. They're different. What are you guys talking about now? Yeah, it's order. It is the order that makes the difference. Let's look at a while loop. Bernard, you're welcome. It's very kind of you, Bernard. It's like the old uncle, you know, sitting around talking about the old days. It's like, oh, really? That's amazing, man. Thanks. Really needed to hear that. All right. If I don't know how many times I'm going to run a loop, instead of a for loop, I'm going to use a while loop. And the while depends on a condition to occur. Often that condition is something that's outside of the loop, maybe even, but I'm just waiting for something to happen. And then I can get out of the loop. So the test here is while foo is not equal to 999. And let's just make that a 9. In fact, let's make it 0. So I'm going to initialize foo to 0. As long as foo is not equal to 999, I'm going to run the loop. It's the same thing we just did with the enter an integer, it's odd or even or whatever. But the loop is now going to run until I input 999 on the terminal. At that point, foo is 999 because I'm reading into foo, and that test will fail. I'll get out of the loop. So this one was while, right? GCC, while. Wow, let's see. Let's run it. All done. Why did it say all done? Because I didn't save it. Somebody mentioned in A1 that there's a way to turn on autosave, which I just must do. Makes me crazy. All right, enter an integer. 4 is even, 6 is even, 9 is odd, 999 is all done. It's odd, and we're all done. So the condition here was, I've got some value coming in from the console. I'm just going to wait until that condition is met, and then I get out of the loop. This loop, there are conditions where this loop will not run, basically. So for example, if I do this, 999, so I'm initializing food to 999, and then I test it. Watch what happens. All done. It's all done because food was already 999. I didn't have a chance even to input it, right? So the condition was met immediately. There are conditions, there's certain situations, actually a lot of them really, where you really do need the body of the loop to run once and then do the test. That's a do while loop. Java's got it, Python's got it, they all got it, right? So here's the do while version of that. Put that so I can see at least. Sweet, here's the do while version. Do I have too many of these? Yeah. Save that. It's roughly the same structure. So in this case, it's going to execute this body, and then it's going to do the test. So even if we have food 999 up here, let's save this and compile it. gcc-o do while.c, do while. So enter an integer. What did we initialize food to? 999. In the while loop, this failed, but we're going to execute the body first and then do the test. So I have an opportunity to get out. 4 is even, 7 odd, 9 is odd, 999, all done. Like I might, let's say my code is setting up a thread pool for database connections or something. I need to guarantee that that code executes at least once so I can initialize the thread pool. And so what I'll do is I'll use a do while. I'll set the loop up so I can monitor like the number of threads and so on and get out when I'm down to 0 threads or something, but I need to set them all up to begin with. And so the do while allows me to get in, set some stuff up, you know, do some conditioning, whatever, and then I start executing the loop. I'm guaranteed it's going to run at least once. So that's really what do while is for, when it needs to run at least once. That is all. Oh, I asked the question like, what does this do? Whiler. It's the category whilers. What's that do? While true. Yeah, it just keeps going, right? I call those server loops because that's really commonly what a server looks like a web server, an HTTP server. Inside that loop, what it's doing is look for an incoming connection on the network. Look for an incoming connection. Look. Oh, here's a connection. Go do something with it. Go back in. Look. It just keeps looking for a connection on the network side, and then once it sees one, usually it's going to spawn a thread or a new process to handle that connection, but then go right back to its loop and just eternally looping. Most servers are written like that because you don't want them to stop. You just want them to keep going. So they're in an infinite loop like that. Sweet. Do that so it doesn't crash. All right, that's the do while. We've done all these. Do while, sweet. Any questions, you guys? Any questions? So I'm going to release PS1 tomorrow for you. PS1 is mainly just using scanf and printf and some conditions and so on, maybe a switch statement. So just the stuff we've talked about to this point, just a little thing to help you do some code. That'll come out on Friday morning. And so your Monday discussion sections, feel free to talk about that. I've asked the CAs and TFs to talk a little bit about Git. I know in some sections, the TFs have already talked about Git. We're going to do a source control. I think Tuesday is going to be source control and talking about Git and GitLab and so on. Might push that to Thursday. So you hear a little bit about that too. But feel free to ask questions about the homework in your discussion session on Monday. Don't forget, oh, your PS0 is due tomorrow, right? Tomorrow midnight, Boston time. If you've had any problems with PS0, like just getting VS Code running or the Docker connection running or something, please drop in on the 5 p.m. session and talk to Devin about it. I'll have to watch the rerun because I'm going to be on the road. I think it's going to be a really good session. He really knows his stuff, which is great. 5 p.m. today, Gabriel. And we're asking him to record it so other folks can watch it too. You're most welcome. Any other questions? All right, that's all I got for today. Go Bucks. Go Bucks. Have a great time. Oh, shoot. Freaking COVID. We can't do Super Bowl parties, can we? Do safe COVID-related activities during the Super Bowl. It usually just means drinking a lot, alone in the dark. That's not what I do. Okay, guys, that's it. Go home. See y'all later. It's been fun.
Bye.
Thank you.
Hey, you're all welcome. Enjoy. All right, let's turn this off. Stop recording.